So in this example here, we are using the data from example one and a 95% level of confidence to find the margin of error for the mean number of hours that were spent on athletic activities by these students in this conference. And they do give us the population standard deviation of 2.3. So that is one thing that is going to be very coming up over and over in this lesson in particular, is that we will be given sigma, the population standard deviation of 2.3. We also have, we know that C is 95%, so C is equal to 0.95. And coming from example one, I'm going to scroll up to example one because let's thinking about everything we need. We're finding the margin of error using the formula that we just discussed. Z sub C sigma divided by the square root of n. So I do need to know n. And the sample size in example one was 40 students. So n is 40 in our problem here in example two. So I will go ahead and put the 40 in down there. We still need to find this critical value Z sub C. I'll leave that blank for now, but we do know sigma is 2.3, so I'll go ahead and fill that in. Let's find the critical value for a 95% level of confidence. If you have your statistic tables with you, this is what I meant. I said earlier my screenshot was cut off. The statistic tables, the first page of the standard normal distribution gives you the critical values for very common confidence intervals. And you see earlier we calculated the 1.645, but this time I can see that I'm going to use 1.96 as my critical value. So I'm going to fill that in right here. So that is the critical value when we are working with a 95% level of confidence. So in other words, before I find, you know what, I'll leave that there. This comes out to be 0.7 for that margin of error. So what we have done is we said, hey, on the standard curve, I want 95% of my data to be in the middle. And then I also, so then what we had to go look up is well, hey, what are these critical values? What are these values that are bounding that region? What are the values that are separating usual data, what's in green, from unusual data, what is not shaded? And you all are going to do the same thing with the try it example from the number one as well. So remember that second example, it had a different sample size. So you will need to take that into consideration when you complete this example on the next slide.